Welcome back, ladies and gentlemen, boys and girls. In today's episode, we're going to be studying all about gases.
I knew what stunk in here.
Not those kinds of gases. By microwaving soap, making water levels rise, sucking eggs through bottles, we'll learn all about the properties of gases. So it's going to be a lot of fun and quite gassy.
But I hope YouTube doesn't have smell-o-vision, because your gases are terrible.
A lot of the behaviors of ideal gases follow three basic laws.
Obviously made by the guys who discovered them.
There's Charles's law, Boyle's law, and Gay-Lussac's law.
First we'll talk about Charles' law.
For the demonstration on Charles's law, all you're going to need is some ivory soap and a microwave.
And the cool thing about ivory soap is that there's tiny microscopic pockets of gas.
And Charles's law states that if you increase the temperature of an ideal gas, the volume will also increase.
Basically, the hotter the gas, the bigger it is.
To make our soap expand as much as possible, we wanted to expose as much of it to the microwaves as we could. So to increase the surface area, I had the kids cut the soap into smaller pieces. "90 seconds is about all you need. It's alive. Charles's law tells us that as the gas bubbles or air inside the ivory soap get heated up, they will expand, and it gives us a nice ivory soap souffle. Now, if you're not interested in getting ivory soap all over your microwave and dishware, you can do the expanding water balloon in a beaker demonstration for Charles's law. First, boil some water, and then take a little bit of that boiling water and pour it into your beaker. Once you have some at the bottom, you can place the balloon in and then put a lid on top to keep as much heat from escaping as possible. While not as dramatic as the ivory soap demonstration, you can slowly see the water levels rising as the balloon gets bigger. And that is Charles's law. As the temperature of a given gas increases, so does its volume. And as the temperature decreases, so does the volume. You can have your kids put a balloon in the freezer overnight to see that effect as well.
And the next law we're going to discuss is Boyle's law.
You know, for somebody who's losing their hair, I really shouldn't critique the hair of others, but can we take a moment and talk about
Boyle's law states, as the pressure on a gas increases, the volume decreases.
For this experiment, you're going to need a balloon and a vacuum container, and you can find one of these at any medical supply store or on Amazon. You're also going to need an air compressor or a hand pump. We used the same one we used during our water bottle rocket episode. Be sure and check that one out. It was pretty fun. Another simple demonstration. Put your balloon in the vacuum container and close it off. And here you can see our setup with the compressor having the tube going in one of the vacuum container ports. Turn it on and watch your balloon shrink. This can be another example of demonstrating Boyle's law. Go to your local pharmacy or medical supply store and pick up the largest syringe they have. Take a balloon, tie it off without putting any air in it. Insert the syringe plunger all the way to the bottom, and then with your finger occluding the hole at the other end, retract the plunger. As you retract, you'll see the balloon start to expand without putting any air in it. An example of decreasing the pressure increases the volume.
Third law is Gay-Lussac law.
It's very similar to Charles's law, but instead of temperature and volume, it relates pressure and temperature. As the temperature goes down on a gas, the pressure it exerts decreases. For this demonstration, all you're going to need is some water, some food coloring, some candles, and a cup or a beaker.
The food coloring just makes it easier to visualize.
So in our water, we went ahead and lit the candles. And then I had them put a beaker in the water to see what happened with the water level so they could observe that nothing changed. The water level inside the beaker was the same outside the beaker. Then we observed what would happen when we put the beaker on top of the candles. As you can see, the water level inside the beaker instantly rises as the cool air develops after the flames are extinguished. This is because the air pressure on the outside of the beaker is now greater than the pressure inside the beaker, resulting in water being pushed into the beaker. This is a simple yet powerful demonstration of chemistry and science. The kids really liked this one. If you study all these laws and put them together, you get what's called the combined gas law. And for that, we're going to be sucking an egg through a bottle. For this, all you need is a flask and a hard-boiled egg. If you don't have a flask, a narrow-nosed glass bottle will work as well. All you have to do is peel the hard-boiled egg, and then we'll be ready to go. I have them place the egg on top of the flask so they see that it will not fall through. For this, all you have to do is light some long matches or strips of paper, place the egg on top, and then watch the science happen. So now that the egg's in the beaker, how do you get it out? Well, we now know with our knowledge of science and the combined gas law, if cooling the gas sucked the egg in, heating the gas should increase the pressure, which will increase the volume and gently push our egg right on out. Well, that's it for our gassy demonstration on Boyle's, Charles, and Gay-Lussac's laws. We hope you enjoyed the video.
If you liked it, then support us by hitting that like and subscribe button, and we'll see you next week.